Welcome to this tutorial for the designer's PCB layout standard. This will cover the PCB requirement phase checklist table. The standard is located at the intranet. If you take a look at the intranet, you would find it several places the access to it, either by using the standards, hardware and PCB standards, and then the designer's PCB layout standard, or from the quick guide here at the front page, standard PCB layout design. If you take a look at the table, the first table is the PCB requirement phase checklist, and if we take it from the start, the first 4 rows cover the milestones, and the point here is to fill out those requirements in terms of time frame, and also when do we actually take the reviews for the various parts of this design. So the reason is here, what are the expectations? Find out at the start so we know what they need, and also sometimes customers, they don't know really whether they may be very busy or maybe not that busy, so getting sort of the information at the start is very important. And also the fact that by setting up the reviews, even though that we don't really know how well it will progress in the design, having these meetings will put a focus not only on the way that we work, but also on the customer in terms of delivering the information that is needed. So being kind of a project manager also for a little bit for taking care of the customer in this case, pushing him to do the right things. This is also very important. So this is why this about the milestone has been added into it. The next line is schematic, and of course, in order to get started with the design, we need to have a fairly well-made schematic. At least we need to have something that can generate a netlist, and that's not always the case. So sometimes there may be footprint missing, other things that could really make it complicated for us to get started. So before we really get into it, what is the status? And the customer may have some comments to this. He may actually say, no, that will be 2 weeks from now, or he says, yes, it's done. And how can we evaluate that this is really true, either by looking at the actual sheets, or of course the best thing is to try to generate a netlist right away to see what kind of issues that may be present. Okay, the next line is about the standards. Now the standards, the reason to having the standards in this is to understand much better from the start what requirements may actually be put on us from the outside. The customer may be aware of what his design is about to do or should do, but maybe sometimes there will be things that can be put on the layout because of other things like the standards. And that could be, say, if you have a PCI card, what are the physical dimensions in the standard? Maybe also clearance areas or non keep out areas and such. And also, you know, other things like plating could be other things. So having understanding what kind of standards that this design should comply to, that is very important. Next line is about the general manufacturing requirements. Now it is like when we do a layout, we have to be aware of how this is going to be manufactured, because we can do some constraint setups that will not be acceptable either by the PCB manufacturer or the EMS. So getting an understanding of what sort of requirements should be set, how we can constrain the layout from the start is very important. It would be a waste of time to start a layout and finding out that this is not possible. So even if the EMS actually can do or should be able to do the job, it's important to know a little bit better what actually he can, so that we can evaluate whether this is the right choice. Anyway, if the customer chooses the EMS, that's what we're going to go for, and we need to know the constraint setting according to his standards or capabilities. The same goes with the PCB manufacturer. It's important to find a PCB manufacturer or know the PCB manufacturer in advance so that we set the constraints accordingly. And also sometimes if the PCB manufacturer is using a specific technology, that may also define how the constraint should be set. Now the next one is the board outline. The board outline is an important information, of course, because it defines really what is sort of the playground for us to work with. And sometimes it's more like a squared box. Sometimes it's a very odd shape. So getting the right information is a good starting point so that we don't work our way through something that will change. Sometimes it will change anyway, but nevertheless it's good to know what input we have, if there's anything available, rather than starting to draw it ourselves from scratch. Same goes with framing, panelizing and break-offs. It's good to know in advance because the placement of those will define where connectors can be placed or critical components can be placed. So again, if we know the stuff up front, then it's easy to do. Same thing, keep out in areas. Can we do those things in advance? If we know these things in advance, it's easy to do things right from the start. Room properties. If anyone is not familiar with the room properties, it's a property that you may apply in some tools, so that you can say, okay, these components must be in the same room, same area of the board. It can also be used for initial placement or grouping of components, so it's a kind of initial sorting of it. It's good to know if the designer, the hardware engineer, has set this up and they actually want us to utilize this property. Then we go into the components. The components, obviously there will be components in the design, but which are the major ones? Are there any of these components that have any specific application nodes? Then they should be followed. Sometimes application nodes are very important to follow, and therefore if we don't find them and follow them, we can be blamed for this. So it's very important to find application node for those major components, and it's also important to ask the customer or the design engineer if they are available, so that we don't have to look around for them. If they already have them, why not just get them from them? Same thing goes with reference designs and other things where we can say, okay, if we do it this way, it's very likely that things will work as well as the reference design. New footprints. Obviously a big task can be creating new footprints. We have a lot of footprints in our libraries, but if there's a new footprint or many new footprints, it also really determines how big the task of the total layout job is. So get the information, find them, or try to figure out which one may be complex to design, so this can be taken into account in the time frame for this design. Other things that can determine or add to the complexity is if some footprints need a specific plating, and sometimes we may have socket connectors, or it may be some other reason that there's a specific some other plating required for components. So again, get the information up front. Board component height constraints. It's important to know not only in the board outline what sort of limitation we have, but also if there are anything mechanically or other boards added on top that determines where to place components because of their height. Mechanical holes will always, pretty much always, be a part of it, and we can also guide the customer. So if he has missed to request these holes, then it's good for us to start talking with the customers about this, so that we can add a sufficient amount of mechanical holes. Tooling holes, fiducial markers. This is a more or less a standard thing, but if the board is not going to be mounted in a frame, tooling holes must be part of the design. Fiducial markers we always add to the board, or pretty much always add to the board, as well as the frame. So, and there will be different reasons for adding them, so it's important to figure out what are the requirements here. Sometimes a customer want to have additional fiducial markers because of specific components that they may have faced problems with in the past. So good to ask. Mechanical constraints. The reason to add this question here is we don't know. Some board could be laid out in a specific way for one application and another way in another application. And here I'm talking about the end user environment. There's a huge difference between mounting a board in a mast of a ship rather than in some laboratory. And therefore, knowing this is important in terms of the placement of components, mechanical suspension and other things. So ask about this. Placement. Sometimes components must be placed at a specific location due to holes in mechanical enclosure, other things, so that it's easy to it fits into whatever it should fit into. And also it's important to ask this question so that we can find out if there are other reasons for doing things like logo, silk screen, things that may be not important in one case but very important in another case. Placement and routing zones. Placement and routing zones. When we start to do a design, there can be other reasons for various reasons for having a specific order of the routing and the placement, and that could be due to electrical interference. It could be due to just simple planning of the design. And also, if we have a mounting problem, could be there would be mounting problems if the board is somehow set up with too many components in one area compared to the other, so that or maybe if a lot of heavy components are placed in the center of the board, it will be a problem in the suspension in the mounting process. Sometimes we have a lot of connectors that are identical, and it would really look stupid if they are placed some kind of random way or kind of arbitrary way over the board. So having a thought about how can we align things more from a cosmetic point of view. Also could be jumpers that are mounted so that they are identical, or maybe that you can use, instead of several small jumpers, you could use a pin header instead of the jumper. So figuring out how to do the alignment. If there are places around the board where we have specific height tolerances, it's also important to identify these requirements so that you can add this into your specification. It's important because if you don't, the PCB manufacturer may not really know, or the mounting, the EMS may not know. So it can be both the placement of the component but also the placement of the pads and holes. Rework and repair requirement. This is very much about how to allow or add sufficient space around components that may need rework. If you have, or inspection could also be, So that you ask for, if customers are having components where they may want to replace them, then it's good to get this information up front so that we can add sufficient space around. DFM, design for manufacturing. It's often the case that a specific customer may have some way of doing things. Either they have been using press fit or wave soldering or whatever it could be, a kind of process that they're using or have used for a long time. That could deviate a lot from what other customers may do. So knowing what they want and how they want to manufacture, what are for them a right way of designing for their manufacturing. So we should know these things up front too. Test points. Sometimes we may also have a feeling that the customer have forgotten to add some test points here and there. So asking if they need them, if they have not added them already, then where is the location correct? Sometimes all test points should be placed at the bottom so that they can be connected through some test jig. Sometimes it's much better to have at the top, so when you are in the lab you can access them from the front rather than turning the board upside down. Again, if it is a part of a production that these should be used, then it's important that the EMS have verified those locations. Peelable mask. Peelable mask is about having a mask that will prevent soldering of some holes. So if you have a wave soldering of the bottom of the board, then having the peelable mask added to some of the area will prevent this wave from attacking the board. So if you have, say, a lot of holes that you would like, it could be mechanical holes or mechanical holes that are electrically connected with pads, you want to cover them up so that they don't get covered with the solder. So depending again if the EMS would do it this way with a wave soldering process, then the peelable mask is important. If the EMS has a selective solder machine that can do pin per pin soldering, then the peelable mask may not be important. So this is really one of the cases where the EMS, knowing what he can do, will determine this peelable mask. So, but it's important to ask if that's the case or we could benefit from using it. Next line, power. What is the expected power consumption? We ask this because we want to know a little bit about the design. We may not know what complexity we need to take into consideration in terms of track with power planes and such. So getting this up front is important. Stack up. Well, stack up is always a very important part of the definition, and sometimes the customer is using a standard stack up that they have used in the past. So knowing what they would like, they may also say, okay, we don't want more than 4 layers. Well, that's maybe a tough requirement for some designs. So, and of course, if they say we don't care, then it's giving us the freedom to increase the number of layers if things get tough. Via types, really also a cost driver, depending on the chosen PCB manufacturer and the complexity of the design in general. The via types will be a very important parameter to figure out. And if we can use micro vias or blind bird vias, is that allowed? That can save a lot of time in the routing process. If that's already something we can do, then that's fine. Through hole aspect ratio. Now, if we start talking about holes and via holes, we also have to be aware that some vias may not be able to be manufactured if the board is very thick. So again, it's important to know what constraints we have set in terms of this due to via types, due to the board stack up. Spacing constraints. Does the design have spacing constraints? Some nets that we have to be very much clear of due to high voltages. Length constraints. If we have matched length, buses, whatever it could be, one of different reasons for having a length constraint added to a net. Physical constraints, impedance constraints, other things like that. Signal frequencies and levels, knowing whether we have some high-speed stuff or some tough 24-volt logics added into the design may be very noisy. So it's good for us to know what kind of problems we could see here. Text requirements. Do we or do the customer need some specific text, logo, other things? Nice to know at day one rather than at the end. Suddenly logo placement may interfere with components and stuff, so getting this up front is really nice. Minimum line spacing, minimum line width, very much determined by the manufacturer, but also a cost driver, so knowing what this is. Copper balancing, really important when it comes to the etching process of the copper layers. So having a copper balancing may be really important if we have a lot of copper in one corner and nothing in the other. Also, it could be important due to the EMS and his heating of the board. If there's a lot of copper in one end and nothing at the other end, the thermal balance of the board is very skewed. So for this reason, it could also be very important to have copper balancing. Staircase is a way of showing how the board is constructed, a way of either just pointing out the order of the layers. This by making a staircase with numbers as copper edge on each layer, and having an opening of the solder mask and pulling back other copper area, you can see through the board and see the numbers written on each copper layer, so that you can verify that the production, the assembly of each layer is correct, so the order of the layer are made correctly. Another way of making a staircase is to make it just as a strip at the very edge of the board. That could be in fact at the frame, so the break-off panel has such a construction. Good thing about this is that you can see not only that the stairs, because then you will make it actually as a stair, you can see that they are ordered correctly. You can also see in a microscope the thickness of the copper layer and also the distance in between, so you can verify pre-pack the cores and copper thicknesses. So this is a very neat way of doing it. So, but anyway, we need to know if the customer want this, or if we want it. We can of course determine that that would be the case, but it's not always possible to find spot for this, to find the room for it. So good to know, very good to know in advance, rather than at the very end when the customer is coming back and saying, oops, we need this. Next one, environmental requirements. It's very important to know where the board is going to be used, because this is also going to determine a lot of the requirements. Some customers may not really know some customers may not really know what the consequences of their design will be. Like if they have very tough environmental conditions, that means that may lead to bigger distance clearance rules, other things like that. So the customer should tell us what this is for, so that we can guide him. So that's why this is so important. Also things like airflow. So if we have some expectations of some thermal problems, and knowing that there will be no airflow, that could lead to some considerations regarding how to position these components. And finally, we have this regulatory requirements. So knowing what requirements we may see from EMC, from mechanical testing and so on, would of course give us a good idea of how to do a lot of things. And obviously, if we have a customers coming up with tough EMC requirements, that may lead to adjusting some of the clearance rules, or maybe the whole stack up should be changed. Other strategic decisions may be changed due to such requirements. So that's pretty much it for this requirement table. So it's a dense and important thing, and it's good for you to look into the various links here and take a deeper look in what these things are. There will be a further description of all of that. Hope you enjoyed. Bye bye.